Today we're going to look at trig functions for any angle and any radius. So add that on there. Since it can be any radius, that means that we are not restricted to our radius just being 1. So this is not the unit circle. Doesn't mean we're not going to use some of the things we learned with the unit circle, but our radius is not 1. So with the unit circle, we know that our x value is cosine, our y value is sine, but if our radius here is not 1, then that's not what's going to happen, all right? So this says, let theta be an angle in standard form, so that means that, or in standard position, really not in standard form. The vertex is at the center of the circle, and this is 0. Then if I have this point P here, I know that this is my x value, this is my y value to create the ordered pair x, y, but the x value is not going to be straight up cosine, y is not straight up sine, unless r is 1, and r is not necessarily 1 in what we are doing here. But if I wanted to find r, and I have x and y, this is a right triangle, so it's just a simple Pythagorean theorem, which would be x squared plus y squared equals r squared, which will totally work on the unit circle as well. You'd get 1 for r. But in sine, to find sine and cosine and the rest of these, it's still your same SOHCAHTOA type stuff. As if this is my reference angle that I'm using for theta, then my sine is opposite of hypotenuse. That is y over r and not just y. Cosine would be x over r and not just x. And tangent is still y over x. The r's would cancel out if we simplified all that. Cosecant is still the reciprocal of sine, so it's the radius over y. The secant, still the reciprocal of cosine, so it's the length of the radius over x. And cotangent is x over y, right? So we're going to be talking about sine and cosine. We're going to be talking about circles. We're going to be finding these values. But remember, you can't just look, like if I have this point right here, and this is my x value, this is my y value, I cannot say that the cosine is 9 and the sine is negative 12. That makes no sense because this isn't on a unit circle, and we don't know what the radius is. We'll see if we need to know what the radius here is once we look at this. All right, so I have this point, 9, negative 12, right? So I know, because I can plot points, that 9, negative 12 is in the 4th quadrant. So I'm not just drawing a triangle here. I'm going to draw it on a coordinate plane. So 9, negative 12 would be right here. Okay, what that means for me for my triangle, and I don't necessarily need to write the ordered pair, what's going to matter to me more here is that this is 9 and this is negative 12. Okay? So since I have that for this triangle, I'm going to need to find r at some point, because it says find the exact values of the trigonometric functions of theta. All right, so I know here that my x value is 9, my y value is a negative 12. Your radius will always be positive because it's a length, okay, not a x or a y value there. So what, and we need to find r. Once we have all 3 of these, we can set up all of these little proportions. So I need to find r, and again, I can do that with Pythagorean theorem. So that's 9 squared plus a negative 12 squared equals r squared. So that's going to be 81 plus 144 equals r squared. So 225 equals r squared. So r equals 15. Yes, it's plus or minus, but since we know that the radius is always positive, we just get a positive 15 here. Then we can set these up. Sine, it was just our y, but it is now y over r, because this is not a unit circle. So this is going to be a negative 12 over a positive 15. So when I reduce that, I'm going to get negative 4/5. And it makes sense that it's negative because I'm in the fourth quadrant, and I know that sine is negative in the fourth quadrant. Cosine, which is just plain old x for the unit circle, is x over r when it's not a unit circle. So that's going to give me 9 over 15. And when I reduce that, that's going to give me 3/5. And it's positive, which makes sense because cosine is positive in the fourth quadrant. Tangent is y over x. So that's negative 12 over 9. And that gives me, when I reduce this, a negative 4/3. Tangent's negative in the fourth quadrant. So that makes sense. Cosecant, reciprocal of sine, so that's negative 5/4. Secant, reciprocal of cosine, so that's a positive 5/3. Cotangent, reciprocal of tangent, negative 3/4. Okay. There you go. All right, so let's look at number 2. We have a point -6, -2. So go ahead and draw that and label it in the correct quadrant. I'll give you a few seconds to get that done before I draw it. Okay, so it should look like this. -6, -2 is over here. So -6, -2. My x value is -6. My y value is -2. I need to find my r value, which will be positive. So I'm going to have -6 squared plus a -2 squared equals r squared. So 36 plus 4 equals r squared. R squared equals 40. So r equals the square root of 40, which when you reduce it is 2 square roots of 10. So I have my x, y, and z. Y, or sine theta rather, is y over r. So that is -2 over 2 square roots of 10. Need to rationalize this, so the 2's cancel out. I'm left with a 1 in the numerator. And when I rationalize, that would give me negative square root of 10 over 10. Cosine theta, that's x over r, so that is -6 over 2 square roots of 10. So when I reduce this, I get -3 over the square root of 10, but then I have to rationalize, so I get -3 square roots of 10 over 10. Tangent of theta, y over x, so that's -2 over -6. And then when I reduce that, that reduces to a positive 1/3. If I look at all of my answers here, this triangle is in the third quadrant, and in the third quadrant, tangent is positive, sine and cosine are negative. So I'm good with all that. Cosecant is the reciprocal of sine. So I could take the reciprocal of this and rationalize, but I could also just take the reciprocal of this, and the reciprocal of -1 over the square root of 10 is just negative square root of 10. Secant theta, reciprocal of cosine. But again, I'll take the square root of this one, so my square root, the reciprocal of this one, so that my square root is in the numerator. So I get negative square root of 10 over 3. And then cotangent, the reciprocal of 1/3, is 3. So I don't know what the angle value, I don't know what theta's value is, but that's fine. Nobody asked me for that. I just needed the trig values of this. This is why it says of any angle. This is not our special angles, and r is not 1. Okay? So let's look a little farther into this. quick little review here of our signs of our functions. Depending on the location of the terminal side of the angle, trigonometric functions can be positive or negative. Using your knowledge of the trigonometric function values, identify the functions that are positive in each quadrant. Okay, so here's what we know. We know that all students take calculus. So in quadrant 1, they are all positive. In quadrant 2, the S tells me it's sine, but then also its reciprocal, which is cosecant. Quadrant 3, the T is for tangent, but also its reciprocal, which is cotangent. Quadrant 4, the C stands for cosine, and also its reciprocal, which is secant. Okay. So it says, remember the phrase, all students take calculus. So question number 3 says, if cosine is greater than 0, which quadrant or quadrants could the terminal side of theta lie in? Well, cosine is positive in the first because everything is, but then cosine is also positive in the fourth, so your answer is the first and the fourth. That is old business. That should be a piece of cake for you. If tangent is less than 0, meaning the tangent value is negative, well, tangent's positive in the first and the third, so it's negative in the second and the fourth. Secant is less than 0, so secant is negative. Secant is the reciprocal of what? Cosine. Okay, and cosine is positive in the first and the fourth, so it's negative in which ones? Second and the third. Oops, that was the third. Second and the third. Okay, so what we're going to have to do with this information for these is like what number 6 asks. It says sine is less than 0, so that means that it's negative, and cotangent is greater than 0. Which quadrant or quadrants could the terminal side lie in? So we're going to make our little x and y axis here. We're going to say, all right, sine is less than 0. Well, I know that sine is positive in the first and the second, so sine would be negative in the third and the fourth. So I'm going to put little dots there. Cotangent is positive. So cotangent's a reciprocal of tangent. Tangent's positive in the first quadrant and the third quadrant. So when I'm looking for the quadrant where both of these things happen, it's the one that's going to have the 2 dots in it, and the answer is quadrant 3. Okay, and I'll show you how that's going to apply to what we're doing here. So it says, use the given information to find the exact values of the 5 remaining trigonometric functions of theta. So we are given cotangent. We are given cotangent, it's negative, and secant's going to be positive. All right, so I'm going to make myself a little thing here. Cotangent, which is the reciprocal of tangent, so tangent is negative. This is how I know this from right here. So tangent's positive in the first and the third, so it's negative in the second and the fourth. Then I have to figure out where secant is positive. Secant is the reciprocal of cosine. Cosine is positive in the first and the fourth quadrants. So my triangle that I'm drawing is in the fourth quadrant. And that's going to matter because of how you set it up, and then I'll give you all the rest of your values. You've got to make sure you're using your quadrants correctly here. So here's my little x and y axis again. I'm going to draw my triangle in quadrant 4. That means that when I have the cotangent is, so if the cotangent of theta is -4, that's really -4/1. So tangent is -1/4. So you can always just take everything back to sine, cosine, and tangent. I know that tangent is y/x. So my y value here would be -1, and my x value would be a +4. Then from that, I'm going to find the radius. So I know that x is 4, y is -1. Then my radius, I'd have 4 squared plus a -1 squared = equals r squared. So 16 plus 1 equals r squared. So r equals technically plus or minus the square root of 17, but I only want the positive one, so it's just the square root of 17. And so r equals square root of 17. So that's how I use all that information to get my x, y, and r. Now that I have that, I can get my answers here. So sine is y over r, so that's negative 1 over the square root of 17. I have to rationalize that, so that is negative square root of 17 over 17. Cosine x over r, so that's 4 over the square root of 17. I rationalize that. 4 square root of 17 over 17. Tangent is y over x, so that's negative 1/4. Cosecant is the reciprocal of sine, so I'm going to take the reciprocal of that one and just get negative square root of 17. Secant, reciprocal of cosine, so I'm going to take the reciprocal of this one, square root of 17 over 4. And just as a little reminder, if I took the reciprocal of this one and rationalized, I'd get the same answer. It's just more work than I need to do. Okay. So there you go. Just adding a little piece to what we did to the front. Okay. So I'm going to have you do number 9 in pieces here. So the first thing I want you to do is figure out what quadrant we're going to draw our triangles in. So take this, mark where cosecant is negative and where cosine is negative, and figure out what quadrant we're going to be working in. Okay, cosecant is the reciprocal of sine. Sine is positive in the first and second, so it's negative in the third and fourth. Cosine, I want cosine to be negative. Cosine's positive in the first and the fourth, so it's negative in the second and the third. So we are working in the third quadrant. That's how you figure that out. Okay, so I'm going to draw my little triangle here in the third quadrant. Then I'm going to have to figure out how to label it. So this is cosecant. I would rather think in terms of sine. So sine theta would be equal to negative 2 over the square root of 5. And I don't care about rationalizing this, because I'm just doing that to be able to get it on my triangle. I just have to rationalize my final answers. So I know that sine is y over r. So my y value is what's negative here. My r is the square root of 5. So I need to find my x value. So I'm going to do Pythagorean theorem and find my x value. So that's going to be x squared plus a negative 2 squared equals square root of 5 squared. So I'll give you a second. You find x. X squared plus 4 equals 5. So x squared equals 1. So x, straight from Pythagorean theorem, is plus or minus 1. Then you have to decide. Now, when it's the radius, it's easy. Radius is always positive. But here you've got to decide, is my x positive 1 or negative 1? And that's why it's important that you draw your triangle and you know what quadrant you're in, because if this point here is in the third quadrant, this is a negative x value and a negative y value, so this is a negative 1. So the values that I have, that I need here, are x, which is a negative 1, y, which is a negative 2, and r, which is the square root of 5. All right, so use that information, and I'll give you a minute to get ahead of me. And then I will write these up here without saying anything. I want you to finish first and then look up here. Okay, so find sine, cosine, tangent, secant, and cotangent. So remember to check yourself after you finish, but finish first, and then you will be done with your notes.